Assalamualaikum and hi everyone. So in this video we are going to discuss the last part of chapter 5.1 alkane, which is free radical mechanism of alkane. Okay, so let us look at mechanism. Okay, so reaction mechanism. Okay, first thing you should understand the word mechanism. Okay, so after this, whenever I mention the word mechanism, that's mean you are going to show step by step reaction, okay, from the reactant terus pergi ke produk. Okay, kiranya tengah-tengah ni sementara dia nak hasilkan produk tu ada banyak step lagi. Okay, so itu ditunjukkan oleh mechanism, and usually mechanism we will show by using curly arrow. Okay, so we call it as curly arrow lah. So sama ada arrow full headed like this or half headed like this, it depends on the reaction. Okay, alright, so for today's reaction adalah halogenation. Okay, the name of reaction is halogenation. The type of reaction is free radical substitution. That's mean in this reaction we are going to substitute Cl into this alkane to produce haloalkane. Alright, so that is what we call halogenation or free radical substitution lah. Okay, so there are 3 steps involved in free radical substitution. There are initiation, propagation, and termination. Okay, so initiation consists of 1 step, propagation have 2 steps, while termination have 3 steps. Okay, so how to remember this? You can use this tips. Okay, IPT 1, 2, 3. That's mean you should know in initiation step there are 1 step only. Okay, propagation 2 step, termination 3 step. Okay, alright. So this is the example that we will use in our mechanism here, but please do some correction here. Okay, so this UV, since UV is considered as condition should be placed below the arrow, and then over here you should add solvent such as CH2Cl2. Okay, but CH2Cl2 is inert solvent. Okay, so that's mean it won't react in the reaction lah. Dia tak bertindak balas pun, dia solvent je. Okay, and then kita tahu Cl2 kita ni adalah our reagent lah. Okay, so our product is CH3Cl and HCl. Okay, but the major product, okay, is this one. Okay, in this case, while HCl is not considered as minor product, but HCl is more on byproduct, or sometimes you may call it as side product lah. Okay, so HCl is not important in our mechanism. Okay, because what we want to produce is this one. Ini just side product dia je. Okay, produk sampingan dia sahaja. Okay, that's mean if you don't show this one pun boleh, nak show pun boleh, tak ada masalah. But this one is compulsory lah, kena show. Alright, so let us start with the first step, initiation. Okay, so light or heat provide the energy needed for homolytic bond cleavage. Okay, so if you can see from this equation here, there is UV here. Okay, so ada UV dekat sini. UV ni is considered as heat lah. Okay, so maksudnya function UV dekat sini adalah provide energy for homolytic cleavage. If you encounter question yang asking for the function of UV in this reaction, okay, you should be able to answer lah. Okay, ini jawapan dia. Provide energy for homolytic bond cleavage. Okay, so hopefully you can still recall what is homolytic bond cleavage. Okay, pembahagian bond yang pecah tapi pembahagian dia sama rata. Okay, half-headed arrow. And then as a result of homolytic bond cleavage, we know that free radicals are formed. Okay, since kita divide dia punya elektron tu sama rata, so free radical akan terhasil. Once this free radical terhasil, barulah reaction tu begin. Okay, so let us start with this step. Okay, so since our reagent adalah Cl, okay, so Cl, and then UV. Okay, so since ada UV, that UV will provide energy for homolytic cleavage. Okay, so we know that in a bond there are 2 electrons. Okay, so when this bond undergo homolytic cleavage, that means the electron will be divided equally. Okay, So you have to use half-headed arrow to show that one of the electron is transferred to Cl, while another electron here is transferred to another Cl. Okay, so that's mean our product will be Cl radical. Okay, so there are 2 Cl radical here lah. Okay, you can write like this, or if you don't want to go through the hassle to write 2 times, okay, you can just write 2 dot Cl like this. Okay, so saya faham lah ada 2 chlorine radical dekat situ. Okay, so mana free radicalnya? Okay, hopefully kamu boleh nampak lah. This is the free radicals. Okay, so free radical ni adalah elemen yang ada 1 elektron ni. Okay, alright. So that is for the first step. Okay, so the next step is propagation. Okay, in propagation there are 2 steps. Okay, so one radical generate formation of another. Okay, so tadi kita menghasilkan this free radical. So this free radical will generate another free radical. Okay, dekat propagation step dia. So stable free radical is preferred to be formed. Okay, you have to relate back to chapter 4. Okay, kita belajar stability of free radical kan. Okay, dia ada function dia dekat sini lah. Okay, so dekat sini untuk produce major product, okay, stable free radical tu perlu terhasil lah. Okay, so maksudnya kalau boleh kita hasilkan tertiary free radical dulu. Okay, kalau ada. Tapi in this case our example is very easy, so memang tak ada lah tertiary, tak ada secondary, dia memang ada satu je. Okay, so itu je pilihan yang ada. Tak apa, nanti saya tunjuk lagi contoh yang lain supaya kamu faham bila kita perlu pilih yang tertiary free radical ni. Okay, alright, so just ingat for now. Okay, so in this reaction kita akan produce free radical, and free radical yang kita preferred adalah free radical yang lebih stable, sama ada tertiary. Okay, kalau tak ada tertiary, secondary. Kalau tak ada secondary, baru opt for primary free radical. Okay, so that bila ada stable free radical, that stable free radical will produce major product. Okay, so jom kita continue. Okay, tadi saya cakap this Cl radical will generate another radical kan. Okay, so this Cl radical actually will reacted with CH4 kita tadi. But now as you can see, my CH4 saya dah expandkan dia sebab saya nak tunjuk dia punya mechanism antara CH bond dengan Cl ni. So saya kena expandkan dia lah. Okay, and then what happen here adalah this Cl radical is unstable. So dia nak jadi dalam bentuk normal balik. Okay. Okay, so what happen here is that this Cl, okay, dia akan trigger the reaction lah. Okay, Cl ni dia nak jadi normal balik. So it will take one of the electron from the hydrogen. Okay, so dia akan ambil satu elektron daripada hydrogen. Okay, push arrow from tengah bond pergi ke Cl. Okay, and then when this bond break, okay, as you can see from the arrow, dia homolytically, okay, sebab Cl ni hanya perlu satu elektron je lagi. So that's mean another electron dia akan bagi dekat carbon lah, homolytic cleavage. Okay, so end up kita akan dapat HCl. Okay, H bonded to Cl. Kenapa dia boleh bond sekarang? Sebab Cl ada satu elektron, H ni bring one electron juga. So dia jadilah HCl, dua elektron dekat dalam ni. Okay, and then this part here dia akan jadi CH3 radical. Okay, so inilah yang saya cakap penting tu. Okay, so this one, okay, ini adalah free radical yang terhasil lah. Okay, kalau boleh kita akan sentiasa opt for more stable free radical. Okay, so that's mean if you can produce tertiary free radical, please produce tertiary free radical dekat sini lah. Okay, kalau tak ada tertiary, secondary, tak ada secondary, primary, tak ada primary, macam ni lah. The only option yang kita ada adalah methyl radical. Okay, alright, so next one kita pergi kepada the second step for propagation. Okay, so kita dah hasilkan this free radical. You need to bring down this free radical down here sebab kita akan guna that free radical again. Okay, and then as you can see, saya punya drawing ni saya terbalikkan, okay, supaya senang saya nak draw. Okay, this methyl radical we reacted with chlorine molecule. Okay, so you might be thinking right now, datang mana pula Cl2 molecule yang perfect ni? Okay, so datang kan dah habis ke tukar jadi radical? Okay, you have to remember dalam satu beaker lah, for example, let's say lah dalam tu ada chlorine. Okay, and then ada UV. Okay, tapi even though ada UV, not all chlorine akan exposed to that UV. Okay, so yang exposed to UV will become chlorine radical. yang tak exposed to UV will still remain as chlorine molecule. Okay, so this chlorine molecule will reacted with this carbon radical. Okay, so this carbon radical macam tadilah, dia akan trigger the reaction. Dia nak jadi perfect balik, so dia akan ambil one of the electron from the Cl. Okay, so what happen here adalah macam ni. Okay, so dia ambil satu elektron daripada Cl, and this Cl dapat balik dia punya elektron satu lah. Okay, so kita dah dapat dah produk kita. Our product is CH3 bonded with Cl. Okay, and then another one is Cl radical. Okay, so itu untuk propagation step. Simple sahaja. The next step is termination step. Okay, termination step ada 3 step. Termination step is the step where we will react radical, free radical and free radical. Okay, to produce yang normal balik. Okay, so that mean semua possible free radical akan reacted with each other dekat termination step. Okay, so let us go for the simplest one, which is Cl radical. So Cl radical might react with another Cl radical to form chlorine molecule balik. Okay, don't forget to show arrow here. Okay, so this Cl radical, they share the electron and then dia dapat Cl. Ataupun kalau kamu tak rajin nak tulis macam ni, you can just write Cl2. Okay, alright, so itu step yang pertama untuk termination lah. Okay, so another possibility of reaction dia adalah between, okay, kita ada another free radical iaitu this carbon free radical. So this carbon free radical, okay, which is CH3, might react with another CH3 radical juga. Okay, so sama macam tadi. So they will share the electrons and then they will form a bond. So that's mean over here you have to draw this structure here. Okay, so now this methyl radical dah jadi ethane. Okay, alright, so itu. And there is another possibility. Okay, so possibility reaction antara Cl radical and this carbon radical. Okay, so kita pun tengoklah. Okay, Cl radical reacted with carbon radical. It will form a bond. Okay, so bila dia form a bond, the bonding is between Cl and carbon. Okay, so somehow ini adalah produk juga yang kita nak. Okay, so ini sahaja termination step. So as you can see, for termination step, okay, our product dah back to normal, dah bukan free radical. Sebab free radical is very unstable, so they cannot exist as free radical for a very long time. Okay, dia akan cuba cepat-cepat berubah jadi yang biasa balik. Okay, so this reaction actually what happen adalah this reaction keep on continue. Okay, dia continue lah sampailah habis. Okay, so ini sebenarnya yang berlaku lah. So kalau kamu perasan before this, kamu belajar reaction, kamu just tahu this alkane reacted dengan chlorine in the presence of UV akan produce haloalkane dan juga HCl as dia punya byproduct. Okay, so kamu just tahu macam tu je. And then saya cakap dekat kamu, in this reaction, the reaction intermediate adalah free radical. Tapi kamu tak nampak pun dekat mana free radical tu kan. Okay, tapi bila kamu dah buat mechanism, now you can clearly see where is the free radical. Okay, alright, so hopefully kamu boleh lebih faham lah this reaction bila tengok dia punya mechanism. Okay, so let us look at the next example. Okay, free radical substitution juga, tapi saya guna example yang lebih complicated sikit so that you can see dia punya perbezaan dengan example yang senang tadi. Okay, so now in this reaction saya fokus on bromination. Okay, so maksudnya bromine akan disubstitute ke dalam alkane ini. Okay, in the presence of UV to produce produk dia lah. Okay, so as you can see ada dua produk dekat sini. So you have to be able to determine which one is major, which one is minor product. Okay, so for major product, okay, kita dah tahu before this saya dah bagi tips. Okay, cara dia adalah you have to classify the carbon. So this carbon is primary, this is secondary, this is primary. So kalau nak dapat major product, bromine ni kena masuk yang secondary atau tertiary lah. Kalau ada tertiary, masuk dekat tertiary. Kalau ni secondary, macam ni secondary je, so masuk dekat secondary. So that Sebab bila dia masuk dekat secondary, that mean kita substitutekan hidrogen yang dekat carbon yang secondary. So hidrogen dekat carbon yang secondary akan menghasilkan secondary free radical sebenarnya sewaktu mekanisme kita tu. Okay. So secondary free radical is more stable than primary free radical. Okay, so that's why dia prefer untuk masuk dekat carbon yang secondary lah dalam case ini. Okay, so that's mean this product here will be our major product. Okay, so let us label this one as major product. Okay, while the next one here adalah minor product. Okay, and HBr is the byproduct. Okay, ataupun side product. Okay, so usually mechanism they will ask for mechanism for major product. Okay, so kita akan fokus kepada mechanism major product sahaja dulu. Okay, so kita teruskan kepada initiation step. Okay, we know that initiation step adalah step di mana free radical tu baru terhasil. Okay, and then barulah dia akan trigger reaction-reaction lain. Okay, so in this case our reagent is bromine. Okay, so bromine reacted in the presence of UV. So this UV function dia adalah untuk provide energy for homolytic cleavage. So since Br dengan Br they have the same electronegativity, so eloklah memang dia akan undergo homolytic cleavage. Okay, so one of the electron is given to Br yang satu lagi, and another Br pun dapat juga elektron. Okay, ataupun macam saya cakap, you can just write as 2Br radical like this. Okay, alright, so settle for initiation step. Okay, so the next step we call it as propagation step. Okay, so in propagation there are 2 steps. Okay, so the first step adalah we need to bring down this bromine radical dekat sini. Bromine radical tu yang akan create another radical. Okay, so this bromine radical we reacted with our alkane here. In this case is propane. We reacted with propane. But now we already know bromine tu akan masuk dekat mana. Bromine akan masuk dekat this carbon kan untuk dapat major. So maksudnya you have to expand the bonding between C and H dekat carbon yang secondary tu. Okay, so you can try to do it like this. Okay, CH3, C, H, H, and then CH3. Okay, tak perlu nak expand semua. Okay, and then kita kena show lah dia punya arrow. Okay, so what happen here adalah this bromine akan macam tu lah trigger the reaction. So dia akan jadi perfect balik. So dia akan ambil one of the electron daripada hydrogen ni. Okay, so dia punya arrow will be like this. Bromine nak electron from this hydrogen. Okay, so the bonding between C and H break. Carbon akan dapat satu elektron juga. Okay, so dah settle yang tu. Next, kita boleh draw lah the product will be HBr as the side product. And then CH3. Okay, so C ada satu elektron. Okay, H and then 3. Okay, so this is the free radical yang kita hasilkan. But this time our free radical adalah secondary free radical. Okay, so which is more stable than primary free radical lah. Okay, sebab kalau kita remove hydrogen from this carbon, okay, kita akan dapat primary free radical. Okay, so which is less stable than secondary. Kalau nak hasilkan major product, mesti yang more stable. So secondary free radical in this case is more stable than primary free radical. So kita opt for secondary free radical. Okay, so settle. Next one, kita bring down this free radical dekat bawah ni. Okay, dia akan reacted with bromine molecule. And then kita buat arrow lah. Okay, so arrow dia adalah this carbon radical akan ambil one of the electron from the bromine. And then this one akan break. Okay, so end up our product will be plus with Br radical. Okay, so itu untuk propagation step. Okay, so termination step. Okay, so in this case, bromine radical, we reacted with another bromine radical to form bromine molecule. Okay, Br, or you can just write as Br2. Okay, so another possibility adalah, okay, so ini, we reacted with carbon yang radical juga. Okay. Okay, carbon radical reacted with carbon radical. Okay, don't forget to draw the curly arrow. Okay, so Now they will form a bond there between carbon and carbon. Alright, so next one adalah reaction between bromine radical and this carbon radical. Okay, so settle untuk termination step. Okay, so as you can see, all my curly arrows in this mechanism is half-headed. That's mean only one electron is transferred. Okay, let's say lah kamu tersasul, kamu letak full-headed arrow dekat sini, so automatically dia akan salah. So please pay attention about that one. Okay, and then basically kita dah settle dah untuk dua example free radical substitution. Okay, so nanti kita tengok lagi lah dalam kelas macam mana nak determine mechanism untuk benda-benda lain pula. Okay. Okay, so I think that's all for this video. Thank you. Bye-bye.